So in this video we are going to discuss about another eye defect. So that is known as hypermetropia. So first you have to know what is hypermetropia. So it is a vision defect in which a person can see the distant objects clearly but cannot see the nearby objects clearly. So you can write it is a vision problem. Vision defect in which a person can see the distant objects clearly but cannot see the nearby object. Clearly. So this is known as the problem is known as hypermetropia. Now what are the cause of the hypermetropia? So cause of hypermetropia. So first cause is that the eyeball becomes too small along its axis. First one is the eyeball becomes too small along its axis so that the distant distance between the eye lens and retina is reduced, and the retina. This is the first cause. Next one is the focal length of the eye lens become too large. Resulting in the low converging power of the eye lens. So I'll explain the thing with the diagram so that you can understand clearly. So what is the normal near point? Near point already I told you, that is in 25 centimeter. So what is the defect? In this defect, the persons uh, can see the distance object clearly but cannot see the nearby object clearly. So he will not be able to see the nearby object clearly, but he will be able to see the object which is far away. So as a result of the above cause, uh, the rays coming from an object placed at 25 centimeter, or you can say the normal near point from the eye, meet at a point behind the retina. That means, suppose this is your eyeball. This one is the lens. This is the axis. So in this case, the ray will meet in here, in this point. This is the eye. In case of near point, 25 centimeter. That means the object which is at near will form, the image will form in here, so we will not be able to see clearly. But if the distance is, this is far away from the eye, that means like this. Far away. So what will happen? A clear image will form here. Clear image will form here. So image is here. So this n dash. So more than, this distance is more than 25 centimeter. So near point of the hypermetropy, you can say the normal near point. This is normal near point, and this one is near point of this one. Ray is must here. Now, how to correct this type of problem? So in the correction, you have to use a convex lens, so that you can correct this type of problem. So what you have to do, you have to, again I'll draw a diagram of the human eye. This is the correction lens here. So this is your n dash. So if you use the convex lens here, so this near point will come to here because of the convex lens. So image will form exactly at the retina. So the person will be able to see the object clearly. So convex lens converges the rays as if they are coming from n dash. So you can write convex lens converges the rays as if they are coming from n dash. So one thing I want to tell you in brief, that here you can see the object can see the person can see the near object, and the person the more than cannot see the near object, and the object, if it is at more than 25 centimeter, the person will be able to see the object. Now to correct this type of lens, this problem is known as the hypermetropia, the problems, why the problems occurs, I told you. The eyeball becomes too small along with axis, because this much small, like this way compressed, so the distance between the eye lens and the retina is reduced. So that is why the image is formed in the back side, and the focal length of the eye lens become too large, resulting in the low converging power of the eye lens. So this type of problems occurs. Now to rectify this, so you have to use the convex lens. Okay, so this is the things I discussed about hypermetropia. So next class we will discuss that what will be the focal length, and what is the power of the lens we are going to use with the when the problem is when in the case of hypermetropia. Okay, so thank you very much.